Hi, my name is Ronan Murphy. I'm co-founder of Getvisibility. I also sit on the Irish Government's AI Advisory Council, and I'm delighted to be joined by our head of AI and Getvisibility today, Vlad. And together we're going to explore the evolving role of AI in data security. And I think it's when you look at AI and data security, it's really transforming the way in which we tackle some of the most complex challenges out there that exist when we talk about data. AI has, as we know, has revolutionized many industries, but its impact on the cybersecurity industry, the governance, risk and compliance industry, and the data security industry, I feel is particularly game changing. Organizations are handling more data than ever and growing volumes of sensitive data. They're dealing with more sophisticated cyber threats. And we're seeing the introduction of many different regulatory standards. And front of mind is the EU AI Act. So I think traditional security methods are no longer adequate for the challenge that organizations are facing. And I guess there's where AI steps in. So Vlad, in today's discussion, I think I'd like to talk about, the AI's journey in regards to data security from in its early use, let's say, of basic automation through to the kind of cutting edge tailored AI solutions um, that get visibility and that you're heading up and pioneering within our AI mesh, and how this kind of innovative approach is enabling organizations to solve very complex problems in a way that's more dynamic, efficient, and secure. And I guess is empowering these organizations to use AI at scale to deal with this complex challenge. So, enough of me, Vlad. I think people have dialed in to listen to you much more so than I. So let's talk about our AI mesh. Let's talk about the concept of why we're building it that way and what the value of the mesh is, and why do we need AI in DSPM or in data security posture management. Over to you.
Right. Thank you, Ronan. I like to talk about this stuff, and we're really proud about what we've accomplished here with our system. Basically, it all boils down to the complexity of what you're trying to accomplish. And you can think about complexity as how much code do you need to write, roughly, to solve any given problem. So let's say you want to think about what a pile of files that you have lying around, what is the footprint that has for your security posture, what could be liability, anything from how insurable that is, and so on. There is a lot of data, and analyzing it from any kind of metric, objective, or otherwise is a complex problem. You would need a lot of rules, a lot of and many different approaches to identify what's going on there. This is whether you're trying to find out if your data has personal information, somebody's details could leak out online in case of an attack, or whether you're trying to see if you're up to date with your export compliances, if you're exporting something or doing any kind of that stuff. It boils down to what is confidential for me, what is sensitive. And this definition is typically complex, and it involves multiple stakeholders in the company. Additionally, it's also a moving target. It tends to change as new regulatory frameworks are put in place, and not just with AI in general. Trade changes, everybody's and basically this can lead to a moving target situation where not only you have to deploy a lot of engineering to keep up with what's going on up there, but also you have to continue to maintain that indefinitely in the field. So this is where we're trying to get AI to help us, because we're trying to set up the problem as more of a learning problem, as more of a delegating to the AI, covering some of our bases, and then reducing the cost of making these actionable decisions with the software.
So Vlad, why not just ask GPT-4 to do all of this for you?
Well, we get that a lot. Our system is very different from GPT-4. GPT-4 is one giant thing, or if you believe the rumors, it's several giant things, but a small number of them. Our system is a large collection of smaller elements, and it's designed to work in a certain way, in a concerted way. Basically, the first answer is speed. In order to get one of these monolithic or almost monolithic AI models to have any kind of cogency, you need to get them to a certain size. It doesn't really the ability to understand the world and provide any kind of common sense appears when the model inflates to a certain size, and the cost per inference in these cases is too much if you want to look at a river of files flowing through the network or anything like that. And then these models are somewhat impervious to scrutiny in the case they have any kinds of biases or hallucinations, or they tend to lie in any way. It's very difficult to understand why they do that and how you can manipulate their gigantic data sets in order to prevent that from happening. It's a very costly engineering decision. And finally, they're not really flexible. I mean, it's very difficult to get to the right point between flexibility and repeatability. We all know that you can change the prompt a little and hint to the model that you want a specific type of answer, and it's going to change the answer based on that. But how do you get the model, such a large model, to behave consistently in line with your definition of confidential without prompting it too much? That's something that's difficult, stabilizing these prompting networks. And that's something that we solve with our model, with our line of models through the tailoring process.
So when you talk about the large language models that we see out there, and we'll take a reference I heard recently from Lord of the Rings, the Ring of Sauron, one model will rule them all, right? I guess what you're saying here is that that one model is relatively inflexible, and the ability for an organization to impart their own bias as how they want, let's say in this case for data security, how they want their data interpreted is actually a far more complex task than simply pointing an LLM at your data because of inflexibility and I guess because of cost, right?
Yeah, you have several ways of doing this. If you deploy some sort of gigantic model inside your company for one of these tasks, you can manipulate the way you prompt it. So basically, you can formulate the questions in a certain way, and it's going to have a natural tendency to reply in a certain way. Or you can fine-tune it, which is create some sort of a data set and feed that data set to the model and change its internal parameters a little bit in such a way that it will have a natural tendency to respond in a specific way. There's a wide range of options into how you would do this. But there are problems with either part of this, because if you rely on zero shot and prompting your way into a solution, then that is fairly unstable. You can change the structure of the replies, of the outcomes, with minor changes in the prompting structure. And it's very difficult to scale wide at the level of an organization to get like repeatable, systematic security policy this way. And fine-tuning, on the other hand, is somewhat more stable, but there are technical problems with that, and there are operational problems with that, in the sense that it's difficult to put together these data sets for fine-tuning and make sure that there's no bias and so on. I haven't seen wide range operationalization of this technology for these reasons.
So Vlad, when we talk about the tailoring process of AI, when we operationalize AI and we need to tailor it, whether it's an LLM or it's a smaller model, I mean, that's an area where you're really pioneering the AI mesh. What is the key difference between tailoring and just fine-tuning AI models? And where do the benefits come in terms of the deployment for an enterprise using that type of technology?
Yeah, that boils down to a bunch of technical mumbo jumbo in the background, and it boils down to numbers. Essentially, when you're fine-tuning a large model, you are changing most of its parameters a little bit for it to reason in the direction that you want it to reason. Our AI mesh is a collection of on the order of 100 to maybe 200 to 30 to 50, depending on the deployment of small models. And our strategy of adjusting this network is not retraining the models themselves or fine-tuning the models themselves, but rather adjusting the network and swapping models in and out. This boils down to still changing degrees of freedom. So we're getting some feedback from an interested party who wants to deploy our system, and we are doing something to the system to change some of its degrees of freedom so that it lands better to the expectation of the customer. But we have a different way of controlling these degrees of freedom. Because we develop our methods, our models to be highly salient, we develop models that look at PII, financial information, and so on, technical information. By adjusting the connections between these models and the relative importance in something that looks like a Bayesian network, we're essentially doing something, we're essentially adjusting parameters for which we know there's a lot of what they call Fisher information. They're very informative towards changing the behavior of the problem between customers and between the expectations of customers. So what we're doing is, you can imagine we're tweaking a smaller number of parameters and reaching more people with that, and therefore making the entire process less expensive and more controllable. And at the same time, the advantage is that you don't have to communicate that much. Your fine-tuning process is typically a data sciencey process where you set up a data set and people have to be very careful for that data set to be balanced and so on. We get out with a lot less because we know what the components are. We know everybody more or less has the same definition of PII. It's just a question of sensibilities and sensitivities. So we get to ask the right questions and fit this process into a convenient cost structure.
So Vlad, I mean, I spend a lot of my time looking at different technology and looking at different ways of solutioning complex problems, either at the cyber or the data layer. And this sounds incredibly logical to me. So why aren't more people using tailoring in, solutioning at this level?
Yeah, basically it's because of the structure of the system itself. It's essentially what we're doing here is we've constructed a system which is rigid except for the connections between the models, which are flexible, and we have a good understanding of how to manipulate them quickly and at low cost to get closer to what the customer wants. You can think about it, again, going into very technical terms, as a low-rank reparameterization of the system. So an aggressively low-rank understanding of the problem. So you have to build the system that way, and the challenge is not necessarily just discovering the small number of parameters that you can tweak to do this kind of tailoring, but making sure that they're salient. And an example I would give is, let's say we're in the cybersecurity industry and we're worried about finding information that is sensitive, let's say in some kind of a military setting and so on. But our system's parameters, our models talk about, I don't know, cooking, carpentry, and all kinds of things that are not really salient to the problem. It would be very difficult to communicate with the customer and tailor the system in such a way where it produces a response. Because we've been working for many years to develop these models, which are in tune with what the customers want, we get to really quickly adjust them. But that is a question of the design of the system itself. What are the components? What is the basic representation inside the system of a problem that gives you the best way to manipulate the degrees of freedom to get to where you need to be. Additionally, there are operational issues. So if you deploy a system like this, you need to be able to develop new models and new nodes very quickly, because it could be that the models that we have aren't good, or they're just phasing out, or they're just not doing their job. We have a large zoo of models. It's not all of them are created equal, and customer feedback certainly helps in deciding what's what. If our cost of creating a new data set and a new model would be prohibitive, then the entire structure would become rigid, and we wouldn't be able to benefit from the advantage of tailoring. But what we did was we developed practices and processes to quickly turn around new models. We have a large pool of business documents from different settings that we're looking at. We are generating synthetic data with large artificial intelligence. We are curating and looking at the data in terms of diversity, bias, anything that could be interesting. And overall, over time, through the accumulation of these processes, we decrease the marginal cost, the cost of training the next model that we need to add to the network, and the time that we need to turn around. And this is an important part of the success for such an approach.
So, Vlad, the next logical question is, are you going to use customer data in the process of tailoring models so that when they're deployed, they hit the ground running? Let's take aerospace or banking or healthcare or oil and gas. Have you used a bunch of customer data to get that tailoring up to speed?
No, we were looking at that, and in the beginning, when we started developing the system, we were looking at it in a pretty conventional data science ML training way. We were thinking that the process, but this was many years ago, right? We were thinking that the process would be pick up some data from the customer and then train a model and then keep some data in my pocket because that would be the out of sample, make sure the model works out of sample, and voila, it's a problem solved. It turns out that not only there are problems with the data itself because it tends to not be diverse enough and with the communication bandwidth, and people don't really like to be put inside the middle of a data science problem. But most of this data is heavily sensitive. It's very difficult to convince people, whether they're from the from the defense industry or from the banking industry or anywhere, to share their data to train any kind of AI model. And we've seen that this attitude has sharpened against sharing data with AI, especially in the last year or so, with the emergence of the GPTs and these shady training policies that the large foundational models providers have, where you're not really quite sure ever to which extent your data makes it to some model or to some database. So we've abandoned that a long time ago. Again, for deep technical reasons, when we restrict our number of degrees of freedom in the system to a smaller number, when we aggressively tailor just a few things, we're doing this new thing called AI tailoring, which didn't exist before. We don't really need that much information from the customer because the platform, the basis that we stand on is already salient, and all we need to do is put the Legos properly in order to get to where the customer is in defining confidential or PII. Therefore, we don't need a full-blown data set. What we're doing is a standard tailoring process where we get real live information from customers in sessions with our data scientists or over email or whatever, and we don't need the actual training examples. And we collect metadata about the behavior of our system. So anonymized stuff that doesn't include in any way the customer data, including the paths or anything of any kind of direct information about the data. So we have reduced significantly the fingerprint of information that we require from the customer side in order to bring the system close to them and the cost. And all of this is because of the specific type of architecture that we deploy.
Super interesting. So, Vlad, can you talk to me about your perspective on the art of the possible? I mean, what we're building within Getvisibility is really pioneering in terms of the data security posture management arena. And we're seeing that now that some of the world's leading organizations are benefiting from this capability. So, where does this all lead to? Where does it go next? And where do you see the next layer of innovation looking at this complex problem?
Right. This is my favorite subject of discussion by far when it comes to our technology, which is its perspective and its potential. If we look closely at what's going out there, what's going out with most of the industry is heading in the direction of the large language models, because there is a lot of potential there in terms of solving real business problems. And our different infrastructure focused on delivering coarse granularity networks of models has its own advantages. The tip of the iceberg is, of course, who watches the watcher. So let's say you have generative AI, a gigantic language model, a large language model solving some kind of business problem. Your business is semiconductors, curing cancer, anything, and you're enlisting some kind of a large AI system to solve that. And then the question is, how do you make sure that there isn't liability generated? What's your security posture, our DSPM product? And eventually it will boil down to how do you ensure the AI in terms of what liability it can generate for the company. And the next logical step is, well, if I make another large AI monitor this large AI, then how do I calculate the liability then? Because I'm just doubling the problem. But our system is different. It works in a different way. It's easier to measure, to understand, to see what the models do. We have gold standard models where it's easier to inspect the data, to get them certified. And it's the kind of system, the kind of narrow AI that you want to be having in the background, guarding the interactions with generative AI, because it's more open to scrutiny. But that's just the tip of the iceberg. That's just scratching the surface, right? Because in reality, what we're doing here is funneling a river of data that's somewhere, that's lying around, or that's transitioning through the corporation, through a massive AI system. And this offers a whole lot of opportunities because it offers a rich, unstructured data is very rich. It offers a lot of opportunities, understanding what's going on at the level of processes in a company and generating insight. And this insight could be very deep. There are threats that could be looming around in the data that are not necessarily just related to security. There could be opportunities to disrupt the behavior of large AI, to generate all kinds of liabilities. We're looking at money laundering, corruption, anything at all. As long as you can sit on a river of data and deploy the appropriate mesh, you can extract these signals. Additionally, there are problems which are typically classical in cybersecurity, which are very difficult to approach without such a system. So one of them is, how do you make sure people are not sharing passwords over email, secrets of all kinds, and so on? And it's a difficult problem because your password could be just an email that says, here's my password, and then you log in onto a word, or it could be just a list of usernames and passwords somewhere that's liable to be shared. There are many different contexts. There's a long tail of contexts where these security API secrets, there could be a database connection string in some code where these secrets could pop up. And what we see is that if we build the understanding of what's around in that context, are you sitting in a code base? Is this someone's My Documents folder? Is this the mailbox of a particularly negligent coworker? Then it is also possible to build a better protection surface. It's providing the ability to answer complex problems of security posture and ensuring the company against really massive risks. That's the umbrella. Ultimately, around that, of course, is generative AI. And what our system offers is the promise that by connecting, creating all these signals from the data, hundreds of signals from the data that is seeing, analyzing it in many different ways, it can essentially tell some AI what the data is without that AI seeing the data itself. So you can imagine that you can have some kind of a large security system powered by some large AI in the company, and you don't really want it to see your sensitive information, but you do want it to reason about your security posture. And this is what we're kind of working on in the background.
So Vlad, just to uh, hone in on that point for a moment, right? I guess right now organizations are trying to embrace AI, right? It's a mandate coming from the top down because you need to do more with less, you need to drive operational efficiency. But AI is coming in many shapes and sizes and flavors, right? So you've got AI LLMs out there in the wild, you've got workspaces, you've got AI at the heart of the business like Copilot. You've got your open source R&D models coming from Hugging Face. You've got your AI, native AI applications, and you've got your legacy applications being retrofitted with AI. But the one commonality amongst all these different flavors of AI is that in order to maximize the return on investment from these technologies, they need access to your data. So I'm guessing that yeah, data access governance, data contextualization, data security has now almost overnight become so fundamentally important because it's no longer about just securing, it's now about enabling operational efficiency by embracing new technologies. So security, in my view, is often looked like you're paying for insurance. And if a storm comes and the roof blows off the house, you've got insurance to cover it, right? Or let's say a ransomware attack. Now, if you are not in a position to understand your data effectively, your ability to embrace these new technologies that drive a competitive edge for your business becomes significantly reduced, or let's say significantly more risky, both from a security and a regulatory perspective. Is that a
That's
fair statement?
exactly it. That's exactly it. So sooner or later, you're facing the problem of deploying one of these AI systems in the company and having it help in some way or in some process, whether it's a core process, it's literally the core thing that your company is doing, or something on the side like helping out with your HR or helping out with your cybersecurity, which is more or less all important through the insurability aspect. Eventually, you're going to have to manage the surface of contact between that system and your data. Your HR AI is going to read your people's personnel files, so it better not be biased because that could lead you into litigation. Your security AI needs to read basically everything that's sensitive, and so on and so forth. And the question is, what kind of a system would you have, making sure that you could put numbers on how this surface of contact between some third-party AI and your precious data, how is this interaction, and also with people involved, prompting left and right from inside the company and from around the company. It's very important to have a system that mediates this interaction and that assesses what the security risks are and what the posture is and so on. A system that creates paper trails, that is able to observe compliance. The compliance and regulatory environment is getting more and more complex around these interactions. And ultimately, a system that can tell you what is your insure, in which way you should insure. So something that tells you, that gives you specific numbers of what's going on and what is the risk that you're looking at. That's perfect. It's perfectly correct that with any kind of massive AI deployment comes the need for such an approach to sit in between the AI and the data and to understand exactly how the data is being used, what data is being used by whom, and how is this information moved around.
So, Vlad, before we wrap up, we're nearly out of time. I want you to maybe just share your perspectives from a cost based view of this challenge, right? So I have an enterprise subscription to ChatGPT, and yesterday I started querying or prompting ChatGPT to help me build some sophisticated spreadsheets. And my couple of $100 a month that I pay for this maxed out in 3 minutes, right? And it said, you need to pay more. And I looked at this and I said, wow, this is a very, the output from this is incredibly powerful and it's very valuable to me. But when I equate it to the cost, there's a big question mark, and I probably only got 10% of the work I wanted to do done. Um, so using sophisticated LLMs to do, you know, solutioning of tasks such as building spreadsheets is expensive business. And I guess the consideration is if you apply these types of technologies to very large scale problems like contextualizing data in the cloud, on the network, and across endpoints, you suddenly run into a very steep um, cost of trying to accomplish this using these type of LLMs because they're probably too powerful or too broad for that type of
Yeah.
problem that you're trying to solve, right?
Yeah. That's quite the case. We are seeing billions of tokens in inference, and the problem is that this is on systems that could be on-prem or in some private cloud that are not necessarily optimized at the level of the economy of scale that ChatGPT has to give you a low cost per token. So the actual cost per token in these deployments, especially when you're facing many files with some internal data center because you're sitting in some corporate security perimeter, can blow up, can inflate. And there are also hidden costs. There are costs of interacting with the security team, interacting with the technical team, and ultimately the cost of us interacting with the stakeholders in fine-tuning and tailoring the system, which can blow up if that is a cumbersome process where the system isn't built to start off in a way that it's easy to fine-tune. So when you add all these together and then you add up on top of these more or less running costs, you add up the tail risk of the system being biased or lying or doing something like that because it's not sufficiently open to scrutiny and not transparent and so on. They can quickly blow up, and I think that's indeed our central selling point. That adding all this stuff up together, it's basically the main discriminator between the two methods of approaching AI.
Excellent. I think that's a great note to wrap up on.
It
Vlad,
is.
as always, thank you so much for your time today. Fascinating discussion.
Thanks, Ronan. Appreciated it. Thank you. Bye-bye.